So right now we are on page 28. Part of this is a graph and part of this is solving a problem algebraically. So I want to do the algebraic version first, and then we'll take a look graphically at how this works. So exercise number 3, it says we have a system of equations, y equals the square root of x plus 3, and y equals x plus 1. So part A says solve the system graphically. We're going to do that after. So for now, we're going to continue our work, if it lets me move this down, and we're going to solve this algebraically. And there it goes. I just want to move it a tiny bit. Only for x, it says. So we're going to set both of those equations equal to each other. So I have the square root of x plus 3 equals x plus 1. So to solve this, we're first going to start with squaring this side and squaring this side. So I have x plus 3 equals x plus 1 times the quantity x plus 1. What we've just done is we've introduced an extra x term. So I'm going to simplify this now. I have x plus 3. When I do double distribution here, I get x squared plus 2x plus 1. So now I have an exponent, so I have to get one side equal to 0. So I'm just going to move my x plus 3 over here. Good times.
I thought you were with a student.
No, just a video. So now I have 0 equals x squared plus 1x minus 2. Let's move this down a little, make some room. Whoops. So when I set I have my equation equal to 0, so now I'm going to factor. It's a trinomial, two numbers that multiply to negative 2 and add up to 1. So plus 2 and minus 1 equals 0. So I get x equals negative 2 and x equals 1. So there are our two answers. Now I'm going to pause this video for a sec and switch to the key because it's a little bit neater to look at. So now, hopefully you can see, I have my answers here, x equals negative 2 and x equals 1. And what I did up here, I looked on the table, I put this first function into y1, this second function into y2, and then I graphed them. The square root is right here. You can see these points. And then my line, x plus 1, is here. And the two graphs intersect at the point 1, 2. So what that means, let's see, is it going to let me write? It's not going to let me write. Our x answer is x equals 1. That's here. So what happened is this answer, x equals negative 2, is called extraneous. Our graph only has one intersection point, but when we used algebra, we found two solutions. The reason why this guy right here, we would have to reject. And this is called extraneous because we introduced another x in our equation. We didn't do it incorrectly. We used mathematical rules, but we introduced an extra answer that actually doesn't work. So let's see. If I go back here, I'm going to plug this negative 2 in, or at least I'm going to try to. Come on. So if I go back here, let me just erase everything. If I plug a negative 2 into this problem, y equals square root negative 2 plus 3. Remember, our point is, so actually, hold on, let me do this a different way, sorry. If I set this equal to each other, x plus 3 equals x plus 1. And I plug a -2 in here. And then I put in a -2 here. What happens is this right here becomes square root of 1 equals -2 plus 1. And the square root of 1 is 1, but -2 plus 1 gives us a -1. It's not true. So that's why we have an extra answer. So what we would have to do is reject our answer. So for this guy right here, we would put a slash in it and write reject. And now let's move on and do the other problems.